Okay, so we're going to do implicit differentiation today, which is going to be very different than what you've seen before. All right, so like I said, I saw this example in a book, and I thought this was a really easy way to explain implicit differentiation because it's really strange when you first see it. So if I started out with the unit circle equation, x squared plus y squared equals 1. And I wanted to take the derivative of both sides of the equation in terms of x. So I want to take the derivative in terms of x, so I write d dx of both sides. Well, you guys know when you take a derivative of a big, long polynomial, like 3x to the fifth plus 2x to the fourth minus the blah, 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 you just take the derivative of each individual term in the sum, right? So that's what we're doing here. We're taking the derivative of the first part, so x squared. And then I'm going to take the derivative of y squared. That's going to equal the derivative of 1. So what is each thing? So the derivative of x squared in terms of x. So if I'm taking the derivative in terms of x, what's the derivative of x squared? 2x. But I can't take the derivative of y squared in terms of x because I don't have any terms that have x in them. So I'm going to leave it like that. And then what's the derivative in terms of x of 1? 0, right. So the question is, how do I do this part? Okay, so we're going to think of y as being some function of x. So you could solve for y and you'd have something with only x's in it. So if I wanted to take the derivative of y, the derivative of y, well, let's say y squared, is going to be the derivative of whatever f of x is squared. How do I do that right side? So how do I take the derivative of something with all x's squared? Close. It's 2 of f of x to the first, and then what? That's right, times f prime of x. Do you guys see that? Yep, so use the chain rule. Okay, so when we do that, we get, so just whatever 2 times f of x is, whatever f of x is, times f prime of x. Okay, in other words, f prime of x is the derivative of y in terms of x, right? So what you really have is 2 times y times the derivative of y in terms of x. So what we just did here is we took the derivative and we got it was 2 times y times the derivative of y in terms of x. So do you guys see how you could possibly see that from the beginning now? Because you just take the derivative like normal, like 2y, but since it wasn't in terms, we didn't have y in terms of x, you tack on a dy over dx. Make sense? Okay. So it's going to be 2x plus 2y dy over dx equals 0. Subtract the 2x over. So you get negative 2x over whatever 2y is, dy over dx. So we're going to have derivatives that have y in them in the end, which is going to look really strange to you. But. All right, so that's going to be my final derivative. So dy over dx equals negative 2x over 2y. Okay, so let's go to another example. Okay, so implicit differentiation. So it says sometimes we have equations that cannot be solved for one variable. So for instance, the equation of a circle centered at 0, 0 with radius 5. So go way back to geometry. How did you write the equation of that circle? X squared plus y squared equals the radius squared, so it would be 5 squared, so 25. That's centered at 0, 0. To the centered at hk, it was x minus h squared plus y minus k squared equals r squared, right? So if you try to solve for y, you actually get two equations. You would subtract the x squared over, then you'd take the square root. But when you take the square root, you'd have to write plus or minus. So you would get two different equations. So the first one would be y equals the square root of 25 minus x squared. And the second one would be y equals negative square root of 25 minus x squared. And you guys probably know that because that's how you would have to put it into your graphing calculator, as two pieces. Okay, so there's lots of equations like this. So there's lots of equations where you could get two pieces. So the next one is the folium of Descartes. And it's defined by the equation x cubed plus y cubed equals 3xy. That one you can't really solve for y. I'm sure you can. I don't know how to do it. So we don't really know what to do. It looks like this graph on the right. Little loop-de-loo. Okay, so luckily you don't have to try to solve for y in an equation like this in order to find the derivative. Instead, you can use a method called implicit differentiation. So in order to do this, we differentiate both sides of the equation with respect to x and then solve for y prime. So y prime, you guys know, is dy over dx. Yes. In terms of x. So think of like rates. So if you were finding the derivative with respect to time, so that'd be dt on the bottom. So like your units would be something like feet per second. So yeah, derivatives are always rates of change. So you're thinking of.
It's like over the x value.
Mm-hmm. So basically, we're doing change in y over change in x, like slope. All right, so 1a. So what we're going to do is we take the derivative of x in terms of x. So this first one is 2x, and we leave it like that. Now what we're really doing is 2x times dx over dx, right? But we don't need to write the dx over dx because that is 1. This makes sense why that is 1. Like change in x over change of x is 1. All right, plus 2y times, we have to say dy over dx. Because we don't know if we had solved for y, we don't know, we don't know how to solve for y, so we have to write the dy over dx, like we just did in that last example. Equals the derivative of 25, 0. Okay, then we solve for dy over dx. So subtract the 2x over. Divide by 2y. So I get dx, or dy over dx equals negative 2x over 2y. Actually, in that last example, I didn't cancel those, did I? You guys like, why don't the 2's cancel? So it's negative x over y. Now you could go through all the trouble of solving for y and then replacing the y with all x's. But you'd have plus or minus the square root of 25 minus x squared, and that would look weird. So we just leave it as negative x over y. So that's part A. Part B says find the equation of the tangent to the circle at the point 4, 3. Well, it's nice that you have at the point 4, 3, right? Because x is 4 and y is 3. And what's dy over dx? Just like before, it's the slope. So I get dy over dx is, what was it, negative x over y? So it's negative 4 over 3, so that's my slope. And then I have the at the point 4, 3. So it's going to be y minus 3 equals negative 4 thirds x minus 4. And we leave it like that. Remember on the AP test, you always want to leave it in that form because a lot of people get the calculus down, but then they'll mess up on the algebra part. So they'll make simple mistakes there. 2a. So find the derivative of the folium of Descartes. So let's see if we can do this. This is a hard one. So x cubed plus y cubed equals 3xy. So I have 3x squared. And remember, that's just dx over dx, so we don't write it. plus 3y squared dy over dx equals, how do I find the derivative of 3xy? What was that? Nope, not just 3. Not 0. Use the product rule, right? So separate it into like 3x times y or something like that. So you have to use the product rule. So the derivative of 3x is 3 times the derivative of y. So how do I write the derivative of y? dy over dx, right? Or you can think of it as 1 times dy over dx. Plus 3x is normal. Oh wait, I just did that. Confusing you. Let's make that one 3x. And then 3 times y, right? All right, so we need to solve for dy over dx. How do I do this? You somehow factor, that's true. But what do we have to do first? You could divide by 3 everywhere, but that's not really going to help us yet. You can do what? Yep, get everything that has dy over dx on one side. Everything else goes on the other side. Okay, so I'm going to subtract the 3x dy over dx to the left side. So I'm going to get 3y squared dy over dx minus 3x dy over dx equals 3y minus, I'm subtracting the 3x squared over now.
Why is it 3x? Because wouldn't it just be...
The product rule? Are you up here? Yeah, it's 3x. Because you do keep one normal, take the derivative of the second one. It doesn't matter what order you do it in, but. All right, so now pull out dy over dx. So you get 3y squared minus 3x equals 3y minus 3x squared. So dy over dx equals, can I divide by 3 as I do this? Do you guys understand that? So it's like you're pulling out a 3 from both the top and the bottom. So you get y minus x squared over y squared minus x.
So you just eliminated common.
Yeah, I can write the step above it if you want, but it's like I pulled out a 3 from the top, and I pulled out a 3 from the bottom, so then I canceled those 3's. Okay, that's it. So find the equation of the tangent line at 1.5, 1.5. So how would I do that? Just plug them in for the slope. You have solved for the slope. It's in terms of x and y. You have x and y, so plug them in. Dy over dx, because that's your slope, right? This one. So y minus x squared. So I'm going to have 1.5 minus 1.5 squared all over 1.5 squared minus 1.5. What do you guys think that answer is going to be without using your calculator at all? 1. Close? Negative 1. Why negative 1? Yeah, it's like 5 minus 3 over 3 minus 5. You'd have 2 over negative 2, right? Same thing. So you have something minus something minus itself squared. And then you have the number squared minus itself. They're just opposite each other. See what I'm saying? So you get negative 1. So look for shortcuts like that. Don't waste your time with your calculator if you don't have to. All right, so that's your slope, and it's at 1.5, 1.5. So it's going to be y minus 1.5 equals negative 1 times x minus 1.5. You can leave it like that. Okay, at what points points in the first quadrant is the tangent line horizontal? Okay, so we have the slope equals 0. That's what Rachel said. So dy over dx was, oops, y minus x squared over y squared minus x. So you're finding when your slope equals 0. So you're finding when the numerator equals 0. So I get y minus x squared equals 0. So y equals x squared. I know I'm in the first quadrant. I mean, you can sketch out what y equals x squared looks like, but it's not really helping you. Yes?
No, just really quickly. So you chose the numerator to be 0 because the denominator can be 0.
Yeah, you're gonna at the end you're gonna make sure that that doesn't make the denominator undefined too. But basically, if you have some kind of fraction that equals 0, so if all of this is equal to 0, that means you had like 0 over 5 or 0 over -2 or something like that, like 0 over something. The denominator's not what's making it 0. You just multiply by what anyway? Oh yeah, a lot of you guys in Algebra 2, you thought of multiplying this over and it would just go away. You can think of it like that, but really you want to keep that denominator because sometimes what makes the numerator 0 will make the denominator 0 as well. So that won't actually make 0. 0 over 0 is not 0. So you need to check that at the end anyway. Okay, so here's the trick. So I know y is equal to x squared. So go back to your original. So I have x cubed plus y cubed equals 3xy. We now have two equations that have x and y in them, right? I'm listening to auto-tune music. All right, so we have two equations that have x and y in them, so we can solve for x and y. So I'm going to replace replace y with x squared. So I have x cubed plus x squared cubed equals 3x times x squared. So I get x cubed plus x to the 6th equals 3x cubed. Get everything on one side. So I'm going to have x to the 6th minus 2x cubed equals 0. Pull out the x cubed. And set each piece equal to 0. So the first one's going to be x equals 0. I don't know why my voice keeps cracking. I'm losing my voice. X equals the cube root of 2. 12-year-old girl back here. Okay. Now notice I said at what points you would go back and find y. But that's pretty easy to do because y is just equal to x squared. So this point would be the cube root of 2. And then since y is equal to x squared, square it. So if I had 2 to the 1/3 and I square it, it's 2 to the 2/3. This is hard. So it's the cube root of 2 squared, which is cube root of 4. And the other point is 0, 0, which it's not really in the first quadrant, it's just the origin. Okay. Tricky one. That's definitely a free response type question. Okay. Okay, number 3. So going back to the basics. So find y prime, which is dy over dx, using implicit differentiation. So if you guys are lazy and you don't like to write the dy over dx, as you guys are doing this, you can write 3x squared plus 3y squared times y prime if you want. I don't mind that. Equals 0. Because you know y prime is just dy over dx. Okay, solve it out. So I subtracted the 3x squared over, and then I divided by 3y squared. And then the 3's reduced down. So you get y prime equals negative x squared over y squared. That's it. Now in this one, let's say it was a multiple choice question, and none of your answers had y left in them. Can you go back to the original and solve for y? I think you can, right? Did you guys see it, that you can solve for y? You'd have 1 minus x cubed equals y cubed, and then how do you get rid of the cube? Nope, not plus or minus. Just the cube root, right? No plus or minus. Why no plus or minus? You guys are like sleepy today. If I had negative 8 and I wanted to take the cube root, isn't it just negative 2? It's not plus or minus. Yeah. Cube root, you don't need plus or minus, only even roots. Okay, so then you might see on your multiple choice, you might see negative x squared all over the cube root of 1 minus x cubed squared, like that. So you might see an answer that looks something like that. So know that they can be in different forms. Now if it had been a square root, it probably wouldn't be in that form because you'd have plus or minus in your answer, which is kind of weird. I mean, they might. Okay. So you guys want to try B? So try B. Alright, so I'll go ahead and start as you guys are finishing up. Okay, so I learned I should write tiny because it's a long one. So the first one is going to be 5y to the 4th times y prime. Plus, now we need the product rule, so I have x squared times y cubed. So that's how I'm separating it. So I'm going to have x squared times 3y squared times y prime plus 2x times y cubed equals the derivative of 1 is 0. And then I have a product rule on the second piece, x squared times y. So I'm going to have x to the 4th times y prime plus 4x cubed times y. Okay, you got that far? Okay, get everything with y prime on the left. So I'm going to have, we're going to pull out as we go. So y prime, I'm going to have 5y to the 4th plus 3x squared y squared minus, so I'm subtracting the x to the 4th y prime over. It's hard with primes because then it looks like y to the 1st, but kind of know what you were doing there. So it's going to be minus x to the 4th equals everything else that doesn't have y prime goes on the right side. So I'm going to have my 4x cubed y that I had before, and then minus 2xy cubed. So 4x cubed y minus 2xy cubed. Everybody got that far? Now it's okay if you took them to the opposite sides. Is that what you did?
Well, I was just going to ask how the x to the 4th got in.
I subtracted it over, and then as I was doing it, I was pulling out the y primes. Like, see how these three things had y prime? I pulled it out to the front.
Oh.
Does that make sense?
Okay. How do you go
Save you
from
some time.
x squared to 3x squared?
Because there was a 3 right here. They were all multiplied together.
So it doesn't matter which one goes on.
Yeah, I mean, you don't normally write like x3y. You know, you'd write 3xy, right? Let's put the constant out front. Okay. So now divide. So I get y prime equals 4x cubed y minus 2xy cubed all over 5y to the 4th plus 3x squared y squared minus x to the 4th. And then I always make sure that you can't pull out any x's or y's or anything like that. On the top, yes, I have x's and y's that I could pull out, but on the bottom, I don't have x's and y's in each thing, right? Like I couldn't pull out a y on the bottom because the last term doesn't have a y. Couldn't pull out an x because the first term doesn't have an x. So that's as good as it gets. Pretty messy. All right, and then C. So derivative of sine of x is cosine of x. Plus derivative of cosine is negative sine. So since it had y in it, I write dy over dx or y prime. I'll do dy over dx this time. equals, you have a product, so you have to use your product rule. So I'm going to have first, so sine of x times derivative of the second, so derivative of second. So negative sine of y dy over dx, because I took the derivative of something with y, plus derivative of sine is cosine of x, times the second one normal, so cosine of y, get everything with dy on one side. For this last one, right there? Nope, because I never took the derivative of something with y there, because this was just cosine of y before. I didn't take the derivative of it. It was always just normal. So think, when are you taking the derivative of something with y and when you aren't? Okay, so I'm going to get all the dy over dx's on the left side, so I'm going to add sine of x, sine of y over. And then I'm going to subtract the cosine of x over. So I'm going to have cosine of x, cosine of y, minus cosine of x. Okay, pull out the dy over dx. Can you divide all at once? Can you guys do all this in one step? So we're thinking we're pulling the dy over dx out, and then I'm going to divide by what's left to the other side. So I'm going to have cosine of x, cosine of y, minus cosine of x, all over sine of x, sine of y, minus sine of y. Okay. And a lot of you guys are going to say, can I cancel? Can I do all this stuff? You could pull out a cosine of x on the top, and you could pull out a sine of y on the bottom, but nothing's going to cancel out. Okay, that's as good as it gets. Yes, Catherine?
On the top, we have sine of x times negative sine of y. You see?
Uh-huh.
And then on the second one, we just have sine
Yep.
of x, sine of y.
So I added this whole thing over, right? So if I had minus 5 on this side, when I move it to the other side, it's plus 5.
Okay.
So that's all I did. Okay,